In this podcast episode, Dr. David Kipping, a professor of astronomy and astrophysics at Columbia University, shares his insights on the search for life beyond Earth, the mysteries of black holes and wormholes, the evolving understanding of the universe, including concepts like the multiverse and baby universes, and the impact of emerging technologies such as AI on scientific research. The conversation ranges from the possibilities and challenges of detecting extraterrestrial life and interpreting UFO phenomena, to deep scientific puzzles surrounding black holes, to thought experiments about existence itself. Dr. Kipping opens by discussing the dramatic progress in the discovery of exoplanets over the past few decades, emphasizing that it was once widely believed our solar system might be unique, but now we understand most stars host planets, often multiple ones. Despite the large number of detected exoplanets, much remains unknown about their characteristics, such as whether the super-Earths are scaled-up rocky worlds or something entirely different like water worlds. Central to his work is the question of whether any of these planets could harbor life. He notes that this quest for life has fascinated him from a young age, and that the field has shifted from focusing on memorizing our own solar system to exploring the vast, diverse array of planetary systems in the galaxy and beyond. He highlights the conceptual and technological breakthroughs enabling these discoveries, from recognizing the existence of hot Jupiters orbiting close to their stars, a concept once dismissed, to advances in photon detection through CCD technology, which drastically improved telescope sensitivity. Touching on the tantalizing hints of possible ancient microbial life on Mars, Dr. Kipping explains that while some evidence, such as bacterial-like shapes in Martian rocks and detected methane emissions, are provocative, they remain biosignatures rather than definitive proof. These observations could alternatively be explained by non-biological geological processes, underscoring the difficulty in distinguishing true signs of life from natural phenomena. He recalls historical events like the excitement around the Allen Hills meteorite, once thought to contain fossilized Martian life, but later understood to potentially result from abiotic processes. This cycle of hope and skepticism exemplifies the scientific method, interpreting indirect data with extreme caution and awaiting more conclusive evidence, such as actual samples returned from Mars. The same level of rigor applies to extraterrestrial life detection methods involving atmospheric gases on exoplanets, where scientists carefully evaluate false positive rates and the reliability of signals. Dr. Kipping reflects on the complexity of life's origin on Earth, noting that life seemed to arise relatively quickly after the planet's oceans formed, but the evolutionary journey to complex organisms like humans took billions of years. This timeline suggests a narrow window for such complexity to develop, especially considering Earth's finite habitability. The anthropic principle plays a key role in this reasoning, as humanity's existence biases our perspective on life's emergence and survivability. He underlines that our planet is currently in the last chapter of its biological history, with complex life forms facing eventual uninhabitability. This realization adds urgency and a humbling context to the search for life elsewhere, as it informs expectations about the rarity or abundance of advanced life in the universe. The conversation turns towards how unusual Earth might be. Dr. Kipping points out features such as Earth's large moon, the presence and influence of Jupiter, the stability of our planetary orbits, and the relative quietness of our Sun, all factors potentially contributing to Earth's habitability and the evolution of complex life. These aspects raise questions about how special Earth is compared to countless other planets. This leads to the Fermi paradox. If intelligent life is probable somewhere in the universe, why haven't we observed overt evidence or contact from them? Dr. Kipping proposes that intelligent civilizations might be rare, temporary, or uninterested in communicating with less advanced species like us. Alternatively, alien life forms may be so fundamentally different from humans, perhaps non-physical or collective intelligences, that our conceptions of communication and interaction are inadequate. Dr. Kipping addresses the modern surge in UFO, or UAP reports, and their place in scientific inquiry. He endorses openness and investigation, especially for national security reasons, but stresses the difficulty in applying scientific standards due to a lack of controlled, repeatable, and well-documented data. Unlike the search for biosignatures on exoplanets, where false positive and true positive rates can be statistically assessed, many UFO sightings remain anecdotal or difficult to verify scientifically. He suggests that scientists' reluctance to fully embrace UFO reports stems partly from the overwhelming rate of false alarms and the challenge of filtering genuine anomalies from natural or human-made phenomena. The complexity of possible explanations ranges from novel atmospheric events to psychological effects or secret terrestrial technologies, and the evidence remains insufficient to conclude extraterrestrial origin. The discussion explores how human fears, hopes, and cultural narratives shape our conceptions of aliens and unexplained phenomena. Dr. Kipping reflects on how UFO stories mirror internal human experiences, anxieties, and aspirations, and how the tendency to invoke extraterrestrials or divine beings to fill gaps in understanding is akin to historical patterns like alchemy or belief in miracles. He emphasizes the importance of humility and skepticism, while recognizing that continued scientific examination can often provide natural explanations for seemingly mysterious events, such as various atmospheric or electromagnetic phenomena. This worldview encourages distinguishing personal experiences from scientific evidence and maintaining openness without jumping to conclusions. Shifting focus, Dr. Kipping explains black holes as real, terrifying astrophysical objects moving through galaxies, absorbing mass and energy. He introduces the black hole information paradox. According to general relativity, information falling into a black hole disappears at the singularity, violating quantum mechanics' principle that information is conserved. Stephen Hawking's proposal that black holes evaporate through radiation complicates this, because if black holes eventually vanish, what happens to the information previously absorbed? He stresses that this paradox lies at the intersection of quantum mechanics and general relativity, making black holes a critical bridge in efforts to unify physics, and one of the most important unresolved questions in cosmology. Building on black holes, the conversation delves into wormholes, hypothetical tunnels connecting disparate points in space and time. Dr. Kipping describes early concepts like the Einstein-Rosen bridge, which are mathematically neat but not traversable by matter. Later theoretical work introduced traversable wormholes requiring exotic negative energy to hold them open, raising profound practical and theoretical challenges. He discusses the plausibility of microscopic wormholes inside black holes, potentially providing a mechanism for information to escape, addressing the information paradox. The nature of these wormholes, and whether they link to other universes or parts of our own, remain unresolved, touching on speculative yet scientifically grounded ideas about the structure of the cosmos. Dr. Kipping expands on the multiverse hypothesis, which posits the existence of many universes beyond our own, each with varying physical constants. This concept helps explain the fine-tuning of our universe's cosmological constant, which supports galaxy formation and life's possibility. Baby universes, small transient universes emerging and collapsing rapidly, are part of this broader speculative framework, highlighting how our universe's apparent specialness could be a result of selection bias. He notes many scientists are cautious or uncomfortable with these ideas because they stretch beyond current empirical verification, but they are influential in attempts to reconcile cosmological observations and fundamental physics. The discussion touches on philosophical and scientific interpretations of reality, referencing ideas like those proposed by Donald Hoffman, that our perception of the world is a constructed simulation shaped by evolved brain processes, which filter and simplify sensory data rather than revealing objective reality. Dr. Kipping connects these notions to the holographic principle in physics, where the universe's information could be encoded on a distant surface, suggesting reality may not be as solid as experienced. Such ideas challenge traditional frameworks and open new philosophical considerations about consciousness, existence, and the limits of human knowledge. Finally, Dr. Kipping addresses artificial intelligence's rapidly growing role in science. He shares personal experiences using AI tools to accelerate coding tasks and data processing, praising their speed and efficiency. However, he also warns of dangers. including AI-generated errors, hallucinated information, and the potential for over-reliance, reducing the training and skill development of new scientists. He highlights ongoing debates about the quality and authenticity of AI-generated research papers, the ethical use of AI assistants, and the challenges in balancing these powerful tools with maintaining rigorous scientific methodology. The discussion acknowledges AI as a transformative yet double-edged instrument in the modern scientific enterprise.